When we're looking at triangle questions that have two or more right angle triangles, we're always going to be using SOHCAHTOA. But what we need to recognize is that we need to make sure that we're looking at where we can make two triangles kind of connect to each other. So this question's asking us to find KL, which we'll call X. And if I look at this triangle here, we've got KL and N. So in the bottom left triangle, we connect with that side. In the bottom right triangle, we connect with that side. So what we're going to need to do is we're going to need to use those connections in order to find stuff in that middle triangle. So if we look at that bottom left triangle, what we have is 47 degrees. So I'm going to just look at this triangle right here. So we've got 47 degrees. We've got our opposite would be over here. Our hypotenuse would be across here, and our adjacent would be here. Now we need to find the hypotenuse. We're given the adjacent, so we're going to use adjacent and hypotenuse. So that's going to be cos. So we've got cos theta equals adjacent over hypotenuse. So that's going to be cos 47 equals 35 over hypotenuse. We'll call it, I don't know, y. And then y, because y is on the bottom, we need to switch it with our cos 47, and we end up with that. Now we're just going to go through and solve. We'd end up with 51.3. So that means that this side here is 51.3. We're going to do the exact same thing with the triangle NML, the one on the bottom right. And we need to find the hypotenuse again. We need to find this side. Okay, we're given the adjacent because this is opposite. We're given adjacent. So we're going to use cos again, and we need to find the hypotenuse. So we're going to have cos theta is adjacent over hypotenuse. Then we're going to have cos 36 equals 50 over, and let's call this Z, I guess. And then Z is going to be equal to 50 divided by cos 36. And we're going to get that to be equal to 61.8. 61.8. Now, all we have to do is find x. Now, a lot of people are going to want to use trigonometry again. But what we can actually do is we can use Pythagorean theorem because it's a right angle triangle. So we've got all of our values of a squared plus b squared equals c squared. So we've got a squared plus b squared equals c squared. X is the hypotenuse, so we would have 51.3 squared plus 61.8 squared equals, and I'm just going to put c, we'll add our square root in, and then when we go through and solve this, we're going to end up as c, or x, or KL, is going to be equal to 80.3, and this is in meters. Okay, so therefore, KL is 80.3 meters. Now this next question is really all about the setup, and it's actually a really hard setup, but after you set it up and like after this note, we're going to learn the sine law, which makes this question a lot easier. But for right now, we just need to kind of read through this question, set it up, and then I'm going to let you finish solving it. So we've got an aircraft from small airports can only fly if the cloud height is 300 meters high or more. To determine the cloud height, small airports shine spotlights at the clouds. So we've got an angle of 70 degrees. Now an observer 300 meters away also looks up and they see the elevation point is 60 degrees. Now the light and the observer are on opposite sides of this observation. So what we have is we have a point here, we have a point over here, and they're looking up at the cloud. So we're going to have one value, another value, and we know that in total, they're 300 meters apart. But we know that this is, let's say, the 60 degree side, this is the 70 degree side, and then we need to find out the height. It wants the height of the cloud, so it wants h. Now h is the same for both of those triangles. Okay, one's on one side, one's on the other. All we know is that this total distance from here to here is 300. Well, what we're going to have to do is let x be one of the sides. So we'll say this, the left side. If x is on the left-hand side of our diagram, from here to here, well, then we know that on the right-hand side, it's going to be 300 minus x, because the whole distance has to be 300, and the only thing that's left is 300 minus x. So what we're going to use is we're going to have opposite. So again, this is the hypotenuse. This is the hypotenuse. So in both cases, we're going to be using tan. So I'm just going to write tan once. So we would have tan theta is opposite over hypotenuse, or adjacent, excuse me. Okay, now in the left triangle, we're going to have tan of 60 equals hypotenuse over x. And what I'm going to do is I'm going to solve for x on both of these triangles, because just like h is the same, x also has to be the same. So I'm going to solve for x, and then we're actually going to just substitute the equations into each other. So here we're going to have x equals h over tan 60. And then on the other triangle, we would have tan of 70 equals h over 300 minus x. Now, I could sub in my h over tan 60, or I could just rearrange and figure out that we're going to get, first I would get 300 tan 70 minus x tan 70 equals h. I've multiplied, equals h. I've multiplied the bottom up. Now I'm going to move the x's over to the right and the h over to the left. So I'd get 300 tan 70 minus h equals x tan 70. And then I'm going to divide both sides by tan 70. So I'd get 300 tan 70 minus h all divided by tan 70 equals x. Now, if I look at those two values, what I can do is I can create a system of equations where I know that x and h are the same for both of these equations. So if I've got x equals h over tan 60, and so that was this one, and then x equals 300 tan 70, knowing that tan 70 is just a number minus h all divided by tan 70, I can actually go through and then set those equal to each other. So h over tan 60 equals 300 tan 70 minus h over tan 70. And what you can do is I'm going to let you go through and actually solve for h here. It is a difficult rearrange, but again, after today, we'll learn a different way to do this that is much easier. But this is good practice with your algebra and your trigonometry.